Hi, this is Anirban. I am a PhD student at Trinity College, Dublin. This is a joint work with Debasis and Owen. Here I will present our work titled Retrievability-based document selection for relevance feedback with automatically generated query variants. Standard pseudo-relevance feedback, that is PRF methods, have in general been shown to improve overall retrieval effectiveness, such as mean average precision. However, these relevance feedback methods can sometimes, at the cost of increasing recall, lead to decreasing the precision at the very top ranks, for example, for ranks up to 5. One of the limitations is that the effectiveness of the PRF algorithms depends to a large extent on the choice of the set, say top M documents, which makes these algorithms less robust and more sensitive to the variations in the chosen set of pseudo-relevant set of documents. A strong pseudo-relevance feedback method such as relevance model essentially involves estimating a term weight distribution PW given Q from a set of M top ranked documents. This is basically IID sampling, and we compute the probability of sampling a term W from the relevance model R by the joint probability of observing W along with the query terms. To mitigate the problem of overdependence of a pseudo-relevance feedback algorithm on the top M document set, we make use of a set of equivalence classes of queries rather than one single query. These query equivalents are automatically constructed either from a knowledge base of prior distribution of terms or iteratively generated from a relevance model of term distributions in the absence of such priors. These query variants are then used to estimate the retrievability of each document with the hypothesis that documents that are more likely to be retrieved at top ranks for a larger number of these query variants are more likely to be effective for relevance feedback. So, how can we create these query variants? We first compute the local co-occurrence matrix between the terms present in the vocabulary of, say, the top M retrieved documents. Similar to relevance model, the usual notation PW given D denotes the probability of sampling a term W from a document D, independent of another term, and the set VM denotes the set of unique terms, that is vocabulary, of the set of top retrieved documents, M. Now, a co-occurrence matrix can be constructed from each term pair co-occurrence likelihood, where the weight between a pair of nodes in this graph indicates the co-occurrence likelihood between the words. To select a candidate query variant, we initiate a random walk from one of the query nodes chosen with a uniform probability. The yellow-colored walk starts from the query term Q2. The walk then visits node W2, that is, a word which has a relatively high co-occurrence likelihood with Q2, as seen from a light shade of gray. The walk then continues to Q1 and terminates at W1, thus generating a query variant in Q1 hat, Q2, Q1, W2, W1 of the original query Q. Another walk Q2 hat starts from Q1 and continues to W2, W3 and W4. This way we construct query variants. Here are some examples of automatically constructed query variants stemmed words. For a sample query, foreign minorities Germany. The equivalence class of a query generated by this stochastic random walk is likely to constitute a fair mixture of both specializations and generalizations of the original query. Rather than relying on using a single query variant at a time and then eventually combining their feedback models, we instead, for each query, make use of the entire set of its automatically generated variants to aggregate a collective belief about the usefulness of a document for relevance feedback. Now, to obtain a candidate set of documents that could be used for relevance feedback, we make use of the concept of retrievability. Intuitively, this equation aggregates for each document D the ranks at which each query variant Q hat retrieves D. A low value of these aggregated ranks, lower the better, for a particular document, say D, indicates that D is retrieved towards top ranks for a large number of query variants. This in turn accumulates evidence for the belief that these documents are strongly related to the information need of the original query, and hence should be useful for relevance feedback. Now we sort the top M feedback documents in ascending order of the aggregated retrievability scores, and the top M dash documents from this set are then used for relevance feedback. We employ a relevance model on the top M dash documents from this set. We call our model the weakly supervised relevance model, WSRM, because the retrieval position likelihoods captured with the aggregated retrievability scores act as weak supervision signals for estimating document relevance. Now, we describe how the weakly supervised relevance model can be applied in the case of contextual point of interest, that is POI recommendation, where additional prior beliefs about the contextual appropriateness of a term can act as weak signals to improve relevance model estimation. In an IR-based contextual POI recommendation framework, a system needs to recommend a set of relevant POIs to a user based on the user's preference history and the current contextual constraints, such as the current location, trip type, accompanied by, such as whether the user is alone on a business trip or on holidays with family, etc. A two-step factored relevance model has been shown to be effective for contextual POI recommendation. It estimates a relevance model based on the user's preference history first, then it estimates another relevance model based on both the initial model and the top retrieved POIs in the current context. Finally, these two models are linearly combined. Note that psi-WQ denotes a prior belief on a contextual appropriateness score of a term W with respect to a context term QU, which we will explain next. There is a freely available resource of term context associations of the form term context appropriateness score. An example of a non-relevant pair is nightlife spot family with a lower score. For our experimental setup, we have normalized these scores between 0 and 1 and formalized this data as kappa. These term context association pairs are used to define the psi factor, which works as the contextual appropriateness measure of the term W for the given contextual constraint vector QU. Note that the similarity or the degree of association between the terms W and S is specifically measured with the inner product between the vector representations of those two terms. The values indicating term pair relations psi WQU computed by this equation are then used to define a weighted graph. After defining the graph this way, we then apply the random walk-based method to initiate a number of different walks from the query terms to generate query variants and to finally select top m-POIs based on their retrievability scores. We then modify the factored relevance model estimation with the weak supervised approach based on query variants. Specifically, instead of applying relevance model over the top m-retrieved POIs, we use the POIs with the lowest rank aggregation scores obtained from the query variants. This weak supervised relevance model is able to take into account the prior beliefs in the contextual appropriateness of terms from a knowledge resource. We observed that our approach consistently improves precision at top ranks in two different tasks, namely Trek ad-hoc and the contextual POI recommendation using Trek contextual suggestion data. For Trek ad-hoc, although relevance model improves map substantially for each topic set, it is seen that the improvements in P@5 are marginal. Second, it is observed that the KNN-based resampling method is able to substantially improve precision at top ranks as compared to relevance model. However, our approach generalizes well on the test data indicates that WSRM is more resilient to parameter variation effects. Third, somewhat to our surprise, we observed that fusion-based approaches tend to work well with manually annotated query variants, when each query variant points to the exact same information need. An interesting question is to investigate how many new yet effective documents on an average is a document selection strategy able to bring within the top m-ranks, which eventually leads to the improvements in retrieval effectiveness. This figure shows the differences between the two sets, top m and top m-, as obtained by the three feedback document selection methods, namely KNN, WSRM, and CWSRM. These differences are measured at a number of different rank cutoff points. The better map values of WSRM or CWSRM indicates that both WSRM and CWSRM achieve the desired trade-off between exploration, that is leveraging information from new documents, and exploitation, that is making use of the top M set. Just to wrap up, we proposed a concept of weakly supervised relevance models by using the notion of retrievability from automatically constructed query variants to improve the quality of relevance feedback. We observed that our approach consistently improves precision at top ranks, for example higher nDCG 5 and P@5 values, in two different tasks, namely Trek ad hoc and the contextual POI recommendation. Thank you for your interest. Please feel free to contact me if you have any questions and suggestions.